श्वेतनिशा मैम की। अब इन लोगों को कभी सीट अपडेट नहीं करते, कभी क्लास तक होती है ऑनलाइन या ऑफलाइन।
इसको म्यूट अनम्यूट करने की तो जरूरत नहीं है, इसको म्यूट अनम्यूट करने की जरूरत नहीं है ना।
वो कह रहे हैं कि वो मैं अनमोल से पूछा था।
Okay, good morning everyone. So we have a delay in this. Okay, so I'm discussing the optional paper mathematics paper 1. Okay, it was on Sunday, the last Sunday. So paper 1 I'll discuss today and paper 2 I'll discuss tomorrow. So over here it's not like I'm going to give you all the solutions. I'm going to give you an analysis of the paper. We'll going to have some observations on which topic they have given more of the questions, which topic they have not given us more of the topics, and then after that I'll also try to give at least idea of every question that has appeared, which book maybe matlab you can find those kind of questions in which book and which topic, right? All these kind of things I'll try to cover everything up. Chalo, let's start. This was the question 1. Now a very common phrase I heard from some of the students that ma'am, linear algebra they asked a theorem. They asked a theorem. The first question was a theorem. So first of all you need to make a difference between a theorem and a result. You see, this is just saying like that. This is a very famous identity, right? Sin squared theta plus cos squared theta equals to 1. This is an identity, right? But now if you should use, which one is better? Yellow is better. Chalo. So what is given to us? The given any set of n linearly independent vectors in a vector space V. So we have a set that contains n vectors and that is a subset of V, and they are linearly independent. That means S is a linearly independent set. One more thing that is given, that your V, vector space V is of dimension n. That means dimension of V is n. Two things are given, right? What they want you to prove that any set means this set. I have taken any arbitrary set. So you have to prove that this S is basis. To prove S is basis, it is very important to write everything explicitly so that you can have an idea that what is actually given to you and what they want you to prove. Simple. So every statement they have written in a statement, you write it in a mathematical form. Deduce the mathematics from it, from the question. So these things are given: S containing n vectors, S is linearly independent, dimension of V is n, and S is basis. You have to prove. To prove a set to be a basis, you need two things: linearly independence, and the spanning of that set is the whole V. Two things are required. Linearly independent is already given in the question. So that means only this is your job, right? Let's say this is not true. Let's prove it by contradiction instead, right? So contradiction, it will be, let us assume that this span of S is not V. So it's not V implies there exists a W that does not belongs to span of S. That cannot be written as a linear combination of the vectors of S. So if W does not belongs to the span of S, that means if I take W with the union of this V1, V2 and Vn, what does that mean? Now this means that this is linearly independent. Why? Because W is not in the span of V1, V2, V3, right? So this is linearly independent. A linearly independent set. Dimension is n given. That means bases will contain n elements. Bases will contain n elements. Base B is bases containing n elements. I have a linearly independent set. I have a basis containing n elements. So basis is span. We know that basis span your whole vector space. I have a set that is spanning the V. I have a set that is linearly independent. We have a theorem that is replacement theorem. Replacement theorem, that the number of elements over here will be definitely less than equal to the number of elements in the set B that is spanning the whole vector space. So number of elements in S dash is strictly less than or equal to your B, number of elements in B. Number of elements in B is n, and number of element over here is n plus 1, contradiction. N plus 1 is less than equal to n. This is a contradiction because n is whole number, right? Simple. This was not a theorem. Application of the theorem, results, definitions, that's it. You just have to merge everything together to get your result, right? The next question. Yes, this was first B part. This question is that T is a linear transformation R2 to R3 such that they have given you the linear transformation on two of the vectors of R2 and you have to calculate T of 2 of 4. Basically they are asking you T of 2 of 4 and what we have done is actually T of x of y. We can find a general linear transformation. It is easy that they only want 2 comma 4, right? So what you can do, see 2 comma 4, you write it as a linear combination of the basis vectors. See 1 0 and 1 1, you prove first of all it is a basis vector, only then there is a unique linear transformation. So to prove it a basis, they are linearly independent. To check the linearly independence of two vectors is very easy. Just see, none of them is a scalar multiple of the other, right? So linearly independent and linearly independent in R2 where dimension is 2, I have maximal linearly independent set. That means this is the basis. This is the second definition. This is also we have done in the class. Second definition of the basis. First is the spanning and the linear independence and the other is the maximum linearly independent set. This is maximum linearly independent, you have the basis. So you can write 2 comma 4 as a linear combination of 1 1 and 1 0. You just need to find this alpha beta. Now you apply T both sides. You can take that alpha outside, beta outside, T of 1 1 you know, T of 1 0 also you know. You just substitute the value and you get your answer, right? This was for 10 marks. See how easy this question was, right? Then question number 1, C part. Limit, not even in 2 variables, in 1 variable. This was the question from the calculus part. Calculus part, this is the easiest question they can ask. What is the easy concept what is easy than this? Limit. After limit we go to the continuity of single variable, differentiability, then 2 variable, 3 variable. They have asked you the limit of single variable, simple. And if you observe, this is the infinity. You take you just apply the limit first as it is. So you see this is an indeterminate form, form of infinity, e raised to the power infinity, infinity, infinity plus infinity, infinity, raised to the power 1 upon infinity, that means 0. This is the indeterminate form of infinity raised to the power 0. How we do these kind of questions? Take the log. Whenever you have the indeterminate form of the power, you take the log both sides. So you take this to be y. You consider y equals to e raised to the power x plus x raised to the power 1 upon x. Take log both sides. Log of y equals to 1 upon x log of e raised to the power x plus x. Now you take limit both sides. If you take limit both sides, you see limit x tends to infinity. If you take both sides, and I now also again I apply directly the limits, it becomes e raised to the power infinity plus infinity log infinity, infinity upon infinity, infinity by infinity. Now you have the infinity by infinity form. Now you have infinity by infinity form. Infinity by infinity, 0 by 0. How to solve this? L'Hopital rule. It's not very hard. L'Hopital rule. You apply the L'Hopital rule. This becomes limit x tends to infinity. It becomes 1 upon e raised to the power x plus x. Derivative of x is 1 and e raised to power x again. Again apply the infinity. Again it is becoming infinity by infinity. Again apply the L'Hopital rule. So now it becomes e raised to the power x in the numerator, e raised to the power x in the denominator, plus 1, cancel, 1 is the answer. But this was the answer for log y. So the final answer would be take exponential both sides. So the answer for this question was e raised to the power 1. Easy. Just the application of L'Hopital rule 2 times. Right? No extra efforts. Don't go to the left hand limit, right hand limit. That is not even required. Okay? So just apply the L'Hopital rule and the question was done. And there was one more question that was in terms of integration. There was one more question. But again, if I see the calculus part in the whole paper, including this question and the one question that was for integration, the calculus part was not a very difficult part. Okay. Usually calculus and the real analysis will discuss in the paper too, but in the calculus you see they were not much of a difficult questions, or even the questions asked, not even much questions were asked. So a simple observation is that if you are preparing for 2023, you have to work on the calculus, because if calculus is not asked here, it may have the chance that calculus will be, they'll put more of a questions of calculus in the 23 exam. Now, D, examine the convergence of the integration. Okay. So you see over here the limits of the integration is 0 to 2, and your function over which the integration is required, the function is 1 upon 2x minus x square, right? So I think on white it is not visible, right? So fx is 1 upon 2x minus x square. The problem is that the limit of the integration, on 0 also this is not defined, and 2 is also not in the domain of this function. 0 also will make the denominator 0 and 2 will also make the denominator 0, that is the problem, right? And they are talking about the convergence of the integration. So you see, we don't deal with the two numbers at a time over which my function is not defined. It is the infinite discontinuity, right? So what we can do, we can break the integration. You discuss it for 0 to 1 separately and 1 to 2 separately, because at 1 I don't think there is any problem at 1, right? So if this is the integration I1, this is the integration I2. So you discuss the convergence of I1 and I2 separately. Okay, let me just discuss the, let's just see, make an observation for I1. I1 will be 0 to 1, 1 upon 2x minus x square dx. Right. So you need to change this 0, because 0 is creating a problem. So you write it as limit epsilon tends to 0, this is epsilon to 1, 1 upon, you can complete the square over here, right? What would it become? This becomes minus x square minus 2x plus 1 minus 1, it becomes plus 1 outside. So it is 1 minus x minus 1 whole square dx, right? So it becomes limit epsilon to 0, this becomes 1 sorry, 0, epsilon to 1. It was epsilon to 1, 1 upon 1 minus x minus 1, 1 minus x minus 1 whole square dx formula. Again, the integration formulas, differentiation formulas, don't take them for granted. Okay, the most of the questions, you know, you are doing the higher level mathematics and you actually forget that, you know, what is the basic of everything, and the whole question will stop right there. What was the formula of this? A square minus x square, 1 upon a square minus x square. This was log of 1 plus x minus 1 and 1 minus x minus 1. Apply the limit 0 to epsilon to 1 and limit epsilon goes to 0. For 1 there will be no problem, it will be log of 1 defined. For epsilon there will be a problem. Substitute the epsilon over here, you will get log of epsilon upon 1 plus 1, 2 minus epsilon, and limit epsilon gets to 0 does not exist. Does not exist. So that means I1 is not convergent. So if I1 is not convergent, no need to discuss the convergence of I2. Even if it is convergent, there is no point. The first part is not convergent. So what was the answer for this? This integral is divergent. This is not convergent. Okay. Again, a simple result. Even the convergence, if I talk about the convergence divergence of the integral, you have to work on the rules. Remember all the rules, limit comparison test, all the tests basically, but over here not a single test was even required. It was a simple question. Okay, so this was the question number 1. Question number 1. I hope everyone knows that question 1 and the question 5, it's compulsory, you don't have any choice, you have to attempt it, right? So all the parts of question 1 and all the parts of question 5, it's compulsory to attempt. A variable plane passes through a fixed point ABC, analytic geometry. The question was from analytic geometry. Again, I told you for the analytic geometry, the intuitive idea is very important. If you are not able to see the things, so there will be a problem. Okay, and it's not like everything you can visualize, but the basic theory part, basic things you should be able to work on the intuition, right? And if I see this, okay, let's see what is the question. A variable plane passes through a fixed point ABC and meets the x's at points ABC respectively. Find the locus of the center of the sphere passing through the points O, A, B, C, O being the origin. Okay, so you can start the question by the equation of the plane. Passes through a fixed point ABC. Now it also meets at A, B, C, they are at the x's. So that means if A is my point P00, 0, B is my point 0Q0, C is my point 00R, let's say. So my plane is passing through these 3 points. These 3 points are what? They are intercept. They are forming the intercept. What is the intercept equation of a plane in intercept form? That will be x by P plus y by Q plus z by R is equal to 1. Equation of a plane in the intercept form, right? But it also passes through a fixed point ABC. So ABC also satisfies this. It implies A by P. See, I am only giving you a rough idea how you can attempt the question. So this was all the information of the plane. Now comes to the sphere. The sphere passing through 4 points O, A, B, C. A, B, C you have assumed, O is the origin. So find the locus of the center. Okay, fine. Find the locus of the center. So let's say if center is C1, C2 and C3, the equation of the sphere would be x minus c1 whole square plus y minus c2 whole square plus z minus c3 whole square equals to r square. This is how, this is just the replica of the equation of circle. X minus x whole square plus y minus k whole square is equal to r square, like that, right? Now 4 points passes through it. One is the origin. Origin will give you c1 square plus c2 square plus c3 square is equal to r square. 1 point A passes through it. That means p minus c1 square plus c2 square plus c3 square is equal to r square, right? After that, just substitute all the points. This is c1 square plus q minus c2 square plus c3 square is equal to r square, and c1 square plus c2 square plus r minus c3 whole square is equal to r square. Now what you have to do, just replace the value of r square in this equation, this equation, this equation. You will get the value of p, q and r, and that's what it is needed. Why? Because see, PQR, you will get the value of PQR in terms of C1, C2, C3, and the question has asked locus of the center, and that's what I need. Locus of center means what? You need to find an equation containing the center. That's what it means. So P, Q and R you have in terms of C1, C2, C3, substitute here, you will get your equation. This is your answer after substituting. Getting the point? Over here, just a second. Over here, you are getting the value of P, Q, R in terms of, because everything else will cancel out. R square, you are just replacing it, right? So I don't think this was a very difficult question. Not a very difficult question. See, even the topics that you are not very familiar with, and you are not, this is not very your strong part. In that portions also the questions can be easy. Now I am not saying the questions can't be difficult from that portion. So you have to leave that. You have to leave that. You can't be perfect in everything, but you have to attain the certain level of your clear vision to every subject in the syllabus, right? So if it's it's difficult to cope up with the analytic geometry, so it's okay, but at least 70% of every subject should be perfect, not less than 70%. Even the subject that you are not very familiar with, you have to put that much of effort. So I don't think this was anything in the question. Okay, I don't think that is required to even solve. This is find all the solution of the following system of equation by row reduced method. This term is as it is mentioned in the syllabus, so you have to focus over here. Row reduced method. What is the row reduced form of a matrix? Where you actually first make the echelon form, then every leading coefficient of the echelon form you will have to make it 1, and whichever column contains that 1 should have only that entry as a non-zero entry. So like this is a row reduced echelon form. Why? Maximum number of zeros in the bottom, then less number of 0, right? Now the leading coefficient, that means for every row first non-zero entry is 1. For every row first non-zero entry is 1. Second point is satisfied. Third point, the column in which this row is present, every element except it has to be 0. That is also true. Okay. So after making this the coefficient matrix, you will make a coefficient matrix, you will reduce it to the row reduced method, then you will solve, and you will observe over here they are not actually linearly independent equations. You will find a free variable over here because the last row it will be 0, 0, 0. Okay, so basic calculations are needed, and you see 15 marks. So free के number थे, free के Now you see the methods, even the mechanics portion that I have observed, even the differential equation I have observed, they have not given you a choice of solving the differential equation by your method. They have given you the specified method, Lagrange's method of undetermined multiplier. When I was discussing the syllabus, I emphasized on this word in the differential equation, that undetermined multiplier, please don't leave it. I have underlined this in the that section, catenary problems are there. I have underlined that also in the syllabus. So those kind of things please don't miss, you know, which are repeatedly asking. They are repeatedly asking. Laplace, there will be definitely a question of Laplace. There will be definitely a question of Green's theorem, Stokes theorem, Gauss divergence theorem. These three questions are like definite. So even if it depends upon your luck again, but again just go through it now. If the simple observation says that it is repeating every year, so why don't you just do it? Simple, right? So Lagrange method of multiplier. What was the question? A wire of length L is cut into two parts which are bent in the form of a square and a circle respectively. Using the Lagrange's method of undetermined multiplier, find the least value of the sum of the areas. Now if I just forget about this now, this becomes the question of class 12th level. This is the question of class 12th level. A wire length L cut into two portions, let us say A and B. One is bent in the form of a square, okay. So A by 4, A by 4, A by 4, A by 4. B is in the form of a circle. So if this is a circle, so that means 2 pi r, circumference is B. So what is your R? R is your B by 2 pi. And what is the area? Because what they want you to find, least value of sum of the area. So area of this will be area of square. This is side square, so a square by 16, and over here area of circle is pi r square, pi r square, right. So it becomes b square by 4 pi. Now why I am saying this is a plus 2 level question? They are saying that you have to minimize the sum. That means you have to minimize a square plus a square by 16 plus b square by 4 pi. You have to minimize this. But in the class 12 we have not done the minimization question of two variables. That is the problem. But over here see, what is the constraint? A plus b is L. So it's not basically two variable, it's one variable. B is equal to L minus A, substitute over here, L is a constant, L is not a variable, L minus A, you will get a function in terms of A. Can't you minimize it using the first principle of derivative or even the second principle of derivative? What we used to do, find the derivative, equate it with 0, find the value of A and then substitute in f double derivative. If it is negative then maxima, if it is positive then it is minima. But that was not the question. That means the approach, you can't write that approach because they have specified the method. The method is Lagrange's method of undetermined multiplier, and for that, if you don't know the Lagrange method of multiplier, nothing can be done in the question. Even if you know that class 12th way, right? So that's what I am telling you, just go through everything that is written in the syllabus. Even if the only upper layer of it, if the question is asked from the upper layer, you can attempt, if not, leave it. Don't waste your time in the exam. So what was that? What is Lagrange's method of multiplier? You take a function f, you take a function g, then you find the value of del f is equal to lambda of del of f. So this is your f of x comma y, a comma b, right. This is your g. Basically what you can do, f is a square by 16 plus b square by 4 pi, and g function is G function is a plus b minus l, right? Then you used to do this, del f is equal to lambda of del of g. First equation in the Lagrange's method of multiplier. Then you find the value of lambda. Over here what it will be? This is just a by 8 I cap plus b by 2 pi j cap is equal to lambda times I cap plus j cap. Equate the value, lambda you are getting a by 8 equals to b by 2 pi. You get the value of a and b. A is 8 times lambda, b is 2 pi lambda. Then you find the value of lambda by substituting this in the constraint. What is the constraint? A plus b is equal to L. A plus b is equal to L. Substitute the value over here, you will get the value of lambda. Again back substitute over here, you will get the value of a and b. For those value of a and b, you will get the least value of your function f. Right. So, it is not very difficult if you know the method. Just the initiation and the job is done. Right. Chalo. Next, this was the 6 normal. Now, I actually don't remember how many times I have focused these kind of questions. This is the example. Solved example is Krishna series, solved example in P.N. Chatterjee, and in fact these kind of questions are asked at multiple times in the previous year questions also. But yes, see, don't put your hand in this question if you don't know it. If you have not done the questions of the 6 normals in ellipsoid, this was the question of ellipsoid, don't put your hands on it. Now what will happen? You will be wasting your time, a lot of time in the questions, and you know at the end we have some questions that are very easily you can solve. Laplace is there, Stokes theorem, Green's theorems, so why to waste time over here? But again, if you have done this question, these kind of questions, this was nothing. I am giving you a rough idea. They are 6 feet. They are feet of 6 normals drawn from a point of a ellipsoid. So let that point be x1, y1, z1, right, and 6 normals. Okay, so let that feet of the normals be alpha, beta, gamma. So you need 6 values of this alpha, beta, gamma, right, and so that is given for the question number . So the alpha, if I start with alpha, the alpha was actually given by a square x1 by a plus lambda, a square plus lambda, and beta was given b square y1 upon b square plus lambda, and gamma is equal to c square z1 upon c square plus lambda. But again you want 6 values of alpha, beta, gamma, right? You want 6 normals. So that depends upon the lambda. Lambda, you have to work on 6 values of lambda basically, and from where you can get the values of lambda? You have that equation also, that is a square x1 square upon a square plus lambda whole square plus b square y1 square upon b square plus lambda whole square plus c square z1 square upon c square plus lambda whole square equals to 1. You see, I have whole square over here. So this is lambda square, again lambda square, lambda square. This is an equation of 6 degree in lambda. So that means there will be 6 values of lambda. You don't have to solve it. You know how to do those questions. Now you have plane, you have 2 planes. Let the equation of one plane is Lx plus my plus nz equals to p, and for the next let's say L dash plus m dash y plus n dash z is equal to p dash. Right, the plane this is it is given now. It is given that it is represented by this. So you have to show that the second plane. So basically you have to show this is equal to the given expression in the question. So that means you have to find the value of L dash, M dash, N dash. Okay, go through the previous concept. This is simple, not much of an effort is required, right? Again, if you have done it, otherwise leave that in the sitting in the exam. Don't waste time over here. Again, linear algebra. Linear algebra, question number 3, and for this batch also I have been discussing these kind of questions, like tons of questions. P is the subspace given by these two conditions. Prove that P is a subspace. If I want to prove that P is a subspace, it's not like check whether it is a subspace or not. They are telling you to prove. So just remember alpha x plus beta y. Alpha x plus beta y, you have to prove that it is again in P. P where x is sum x1, x2, x3 and y is sum y1, y2, y3. So basically if you substitute the value and you open it up, the coordinates basically what you are getting in a 3-tuple form. You are getting alpha x1 plus beta y1, alpha x2 plus beta y2, alpha x3 plus beta y3. That has to satisfy these two conditions. So that means it has to satisfy x minus y minus z. What does that mean? That means alpha x1 plus beta y1, this is first component, minus the second component, minus alpha x2 plus beta y2 minus alpha x3 plus beta y3. You have to prove that this equals to 0. You can prove it. You can just merge this, take alpha common out, because this already belongs to P. So for this x1 minus x2 minus x3 is 0. Do the same for the second equation, second condition, right? Second condition should also be satisfied. Once both of them are satisfied, so you have alpha x plus beta y belongs to P and first is done. Basis and dimension of P. Basis and dimension, how we do that? You eliminate your eliminate your variables from here. You eliminate z. I want to eliminate this condition. How I can eliminate? Z is equal to y minus 2x. Z is equal to y minus 2x. First condition is x minus y minus z is equal to 0. X minus y minus z is equal to 0. So if I want to eliminate the second condition, that means I don't have to write x, y, z now. I will write x, y and the value of z, y minus 2x. Now I don't require the second condition because I have substituted the second condition. That's how you do. That's how you calculate the basis and the dimension. And you are only left with one condition, x minus y minus z is equal to 0. Right? Over here also, z should not be visible. So you substitute the value of z also. So that is y minus 2x equals to 0. So this condition becomes x minus 2y plus 2x is equal to 0. This becomes 3x minus 2y is equal to 0. This is the first condition. Second condition you have eliminated because this is the value of the second condition, and this first condition becomes this. From here eliminate y. It becomes 3x upon 2. Now I don't want to write this condition also. I will replace my y as 3x by 2 everywhere. This also, this also. That will give you the linear combination of one vector. Only the x will be the scalar over here, and you can get a basis and the dimension as well. Okay. So again from the linear algebra, very easy question. This was the question I was talking about. Double integration. This was class 12th. This is the question from class 12th. Double integration to calculate, okay, double integration is not, the word double integration is not there, but more or less you are doing the same thing over there also. So to calculate the area common to the circle x square plus y square is equal to 4, x square plus y square is equal to 4, and so this is minus 2, this is 2. and the parabola y square is equal to 3x. So, y square is equal to 3x like that. What I have done. Okay, I think that I have deleted that somehow. Okay, so chalo, no problem. No problem. The question was actually this: you have to calculate the area that is common to x square plus y square equals to 4 and y square is equal to 3x. This was your question. You have to calculate the area between the common area. What is the common area? You can see this is the common area. You can work with the horizontal strip also, vertical strip also. Okay, but I think over here horizontal strip will be better. So, what you can do, lag raha hai na zyada, the horizontal, if you take the horizontal strip, see what I am trying to say here is, if you take that horizontal strip, you have to solve it by the double integration, right? This point, you solve this point is 1 comma root 3 and this point is 1 comma minus root 3. You can solve those two equations to get the point of intersection, right? After that, how that horizontal strip is helping you? Double integration 1 dx dy. For dx, find the value of x of this curve and then this curve. The value of x from here is y square by 3 and the value of x from this curve is root of 4 minus y square. Only the positive, because I am on the this section is the positive section of your x-axis, that is why I have taken only the positive part. So, after that what? The limit of y? Limit of y, you can see, just move your horizontal strip up and down, you are getting minus root 3 over here and root 3 here. So, this is from minus root 3 to root 3, you have to solve this double integration and done. And in class 12th, what you used to do? In class 12th, actually this double integration was not the concept. So, you do not write 1 over here, instead you write, you see, if you solve this much of part, this is directly the upper limit minus lower limit. This is what you used to do, minus root 3 and upper limit, that is 4 minus y square by 3 d of y. So, one extra step is required over here. Basically, you start from the second step in class 12th, right, and solve the integration. Now, please do not make me solve the integrations, okay, integration differentiations. Chalo. This was the question. Then this was the question that I can say it was not asked. This kind of question was not asked before. So, this was a target. This was a good question. Find the equation of the sphere of the smallest possible radius which touches the straight lines. Two straight lines are given. Okay. See, we have a sphere and two straight lines are given to us, I want the radius of this sphere as the minimum. What does that mean now? For example, these are the two lines, right? So, let us say these are the two lines. If I want to minimize the radius, there is one basic observation you can make, that if you join these 2 points, that line has to be perpendicular to both of the lines, diametrically opposite. This was the only basic observation from this point, smallest possible radius. Okay. So, this was enough for the question. If you are able to make that observation, there was nothing in this question. Yes, it was not the question, it was some different kind of question, but it is not like they have asked some out of the syllabus concept. You have to use the ideas. You have done so many questions in analytic geometry, you have practiced so many questions. So, it is just the basic idea that you need here. What was the basic idea? That the line joining of these points where it is intersecting your sphere, let it be P1 and P2, they are diametrically opposite. That is it. So, how you can start? Line 1, if this is the line 1 and this is line 2, L2. So, one basic observation, if you equate it with let us say lambda and if you equate it with let us say mu, so L1 is generated by 3 lambda plus 3 for the first one, minus 1 lambda plus 8 and lambda plus 3. For L2 it would be minus 3 mu minus 3, 2 mu minus 7 and 4 mu plus 6. Basic observations. You take that you take that vector, a vector P vector and a vector Q vector along with these lines. Okay. You can calculate P minus Q, vector P minus Q. Just subtract this, right? You will get first component, second component, third component with respect to I cap, J cap, K cap. But the observation says that this line is perpendicular to this. Two vectors are perpendicular, dot product is 0. This that you have obtained over here, do the dot product with this, the answer is 0. If the answer is 0, over here you will get an equation in terms of lambda and mu. Same, if you take the dot product with this line with the q vector, this is this q vector, again second equation in terms of lambda and mu, you can solve it for lambda and mu, get the values of lambda and mu, and after that what they are asking, equation of sphere. Okay, after you have lambda and mu, you have this P1 point, you have this P2 point, center is in middle of it, and you can find the radius also. You have the center, you have the radius, and you can get the equation of the sphere. So, again not a very difficult task. Over here see the radius, it will be given by r square, it will be given by p upon 4. Okay, I have done the square, so square both sides. So, yes, a different kind of question, but again approachable. If you have no idea about this question, I think complex analysis can help you. Complex analysis in the paper 2 can help you. I am not saying that it is not done by any other method, but that can help you. You see, try this. If this is a point P and it is rotated with an angle theta, so if it is r e raised to the power iota theta, iota phi, so it becomes r e raised to the power iota phi plus theta, iota phi plus theta. So, that means initially it was something like that. this is phi, the angle was phi, but again I want to rotate it with respect to rotate it by an angle theta. So there will be only change in the theta over here. That's what the question asked. Find a linear map R2 to R2 which rotate each vector of R2 by an angle theta. Basic observation, right? Now what you can do, you want a linear mapping such that which changes this to this. This is nothing but x comma y. You have to find the coordinate in terms of the Cartesian product of that. Just open with the help of e raised to the power iota theta equals to cos theta plus iota sin theta, right? This will give you the x coordinate, this will give you the y coordinate, and you can get the answer. Also the r and the phi. At the end, replace your r with x square plus y square and phi with tan inverse y by x. Okay. So what I want you to do, change this polar form into that Cartesian form to get your x and y. What are the coordinates you are having in Cartesian form, right? So that is the answer, just the conversion of it. Okay. Trace the curve. Trace the curve usually is very very difficult topic for most of the students, but the question they asked this time is easy. Why? X square y square is equal to x square minus a square. The question was x square y square equals to x square minus a square. There are only 6 points you have to verify, you have to check for the curve tracing. First, symmetry. Symmetry, you see, if you replace x with minus x in this equation, no change. If you replace y with minus x, no change. That means whatever is the nature of the curve, it is same as above the x-axis and below the x-axis. Mirror image along the y-axis also. All you need to figure out that how your curve looks like in first quadrant, and you can make, because whatever it is in the first quadrant, you can make the mirror image, and whatever you have obtained in the first and the fourth, you can again make a mirror image, and the job is done. So first point, the symmetry point says that only first quadrant, work on only the first quadrant. That's the thing. Then if it is passed through the origin, my equation does not pass through the origin. If it passes through the origin, a has to be 0, and I don't have any a particular value, it can be any real constant. So C, tangent at origin, it does not passes through the origin, then how can it be tangent at origin? What was the fourth point? Fourth point is coordinates, intersection with the coordinates. If you put x is equal to 0, what you are getting? A is equal to 0, nothing. If you are putting y is equal to 0, you are getting x is equal to a and minus a. That means your curve passes through this point, a comma 0. Just the mirror image. Whatever I am getting over here, I am taking the mirror image. What else? After that, you have asymptotes. Asymptotes, very important. Equate the highest coefficient of x square, x and y, both the sides. I don't have y term both the sides, so parallel to the y axis, forget about it. For the x, we have y square over here, coefficient is y square and coefficient is 1 over there. So this is y is equal to plus minus 1. This is the asymptote. So y is equal to 1, y is equal to minus 1. These are the asymptote, that means your curve cannot touch this, okay, and it will touch your this at infinity. Now there is a 6th point also, existence of the region. Please do work on that also, write few points that yes, it does not exist in this region, right. So the nature of the curve was like that, okay. So same like this. Only 6 points are required and the question is done, okay. Now Okay, again cone. Yes, the analytic geometry, some of the questions were out of the scope, some of the questions were not asked those kind of questions, but not this one. This is just a cone, a plane is intersecting this cone, you know, like a blade, right? And they are talking about perpendicular generators. So you have to work on the condition of the perpendicular generator, whole lot of formulas, equation of cone, equation of the generators, equation of the condition of being a perpendicular generator. All these conditions were required in this question, and you can easily get this result. Okay, so no discussion for this question is required. Now the section B starts. In the section B, you can see the first question itself. Mandatory section, mandatory question you have to attempt, okay, not attemptable. In the first attempt, I don't think, if you don't know the proof, or you have given like 3 to 4 minutes to this question and it is not solvable, leave it. See, this is UPSC, na? You can't say that they cannot ask the proof from the differential equation part. It is very few and far between that the topic differential equation, they ask the direct theorems kind of things, and this was a theorem. Okay, so proof of the theorem, if by any luck you know the proof, do it. You want to try the proof, do it. Just spend 3 to 4 minutes, maximum 5 minutes, right? And if it is not possible, move ahead. Okay, so yes, this question was not attemptable in the first attempt, but if you get some time, you can try this. But this is the direct theorem. We'll do that in the class. So this is the direct theorem. Orthogonal trajectory, again, not regularly, but they ask the question from this one also. Orthogonal trajectory, how to solve this? One way, it has x square equals to 4y, y plus a. It has only one constant. One constant means only one derivative is required. Dy by dx is required. You find dy by dx, replace that dy by dx by minus dx by dy, and you solve the differential equation. You will get your orthogonal trajectory of the system of the parabolas, right? So what was the method? You find dy by dx, what it will be? 2x is equal to 4a dy by dx plus 0. So what is your dy by dx? Dy by dx is x by 2a, right? And then you have to replace your dy by dx by minus dx by dy and solve this. There was no, this is just the, what do we call? Separation of separation of variable, right? You just separate the variables, nothing in this question. Again, this question was same as like the Lagrange's method of multiplier. The questions of Lagrange's method of multiplier are not that easy that they have asked, but if you know, at least you can make the attempt. Over here also, at least if you know the method, you can attempt. If let's say after this point it is very difficult, you are spending so much of time and you are not able to solve this question, then you decide to leave the question. But initially, at least every question should be so familiar that you can at least target that question. So that's what I am saying. Creamy layer, creamy topic of every subject is very important you to go through. Okay, and this was one of that. Okay, so at least if you want to leave, if you are leaving any question after making some attempt, at least the reason should be justifiable, right? It's not like because किया ही नहीं था, पता ही नहीं था, सुना ही नहीं था इस topic के बारे में. The reason should not be like that, right? Reason should be, yes, सुना था, I know the method, but I stuck after this. No, it should be some mathematical reasoning. If you give me that, ma'am, I was not able to solve this question because I don't remember the formula, or this. This cannot be the excuse of a UPSC student because I don't remember the formula. So it should be like, ma'am, difficult tha, then we can talk about those things. Chalo. Mechanics. मैकेनिक्स का क्वेश्चन था ये. It was asked a body of weight W rests on a rough inclined plane of inclination theta, the coefficient of friction mu being greater than tan theta. Okay, find work done in slowly dragging a body B up the plane and then dragging it back to the starting point, the applied force being in each case parallel to the plane. Okay, so if you have done the topic of friction in the mechanics, nothing. This question was nothing. Again, I'll show you the questions of mechanics where some efforts were required, but I don't think that over here it was required. I don't think over here anything was required. See, a body of weight W rests on a rough inclined plane of inclination theta. This is the body. Weight is given. When you have a body on a rough inclined plane, how many forces are you know that they act? Without this, we are not dragging the body right now, just if it is right there. So there is a weight acting vertically downwards, weight acting vertically downwards, mg, which is given to be W over here, right. One is the reaction, they act in the perpendicular direction of your this is the perpendicular direction, this is R, right. And after that this was the initial, even if I am making no motion in the body, this was required. These are the forces already acting on the body. Then they are telling you that it is dragged a body a distance b, okay. So a distance b above, so let us say at this point, and then again back to the same position. So if this position is A, this position is B, from A to B, from B to A, they are dragging the body up and down and in slowly dragging the body means there is no change in the kinetic energy. That means you don't have to work on that additional factor of the kinetic energy. That slowly word is very important over here. You don't have to make any change in the kinetic energy. But after that you see mg, you are dragging the body from a point A to a point B and then again dragging it back to A, right. Starting from A, again whatever is your path, you are coming back to that initial position. The conservative force is 0. What is the conservative force over here? mg. mg is the conservative force. That means no work has been done by the mg. But friction has done its job because mu was given. So friction, what is friction? Friction is mu r. R is mg cos theta. Again, you remember all the formulas, you remember the concept of the friction. Nothing, it was nothing in the question. In the dragging the up body, you calculate the friction, the force, the first force, right, work done, and dragging back, mg is not making any contribution in the whole of the system. So for the m2 again apply the formula, add the both of the work done, that is the total work done, nothing, right. So mechanics, for mechanics this was the question. Again, this requires a bit of a thinking. This question requires a bit of a thinking. A projectile is fired from a point O with the velocity 2g root of 2gh. Okay, so velocity is root of 2gh, right? And hits a target at a point P. Hits a target at a point P. In the plane, the x is OX, OY being the horizontal and the vertical downward lines through the point O, okay. And show that, so this is your OX, OY, just like the x-axis, y-axis. Show that if two possible directions of the projectile be at right angle, then x square is equal to this, and one of the possible direction of the projection bisect the angle POX. Okay. So for P to make a tangent, only then you can talk about this now. Otherwise, this is a curve. A projectile is curved. So make a tangent to actually define that angle POX, and this requires some of the thinking. This will require some of your work. So far I think that first question, section B, first question, differential, where you have to prove, that requires some thinking, right? That requires some work to be done. When I am saying thinking, that means I am saying sitting in the exam. Sitting in the exam, if you want to spend some time on the thinking, this requires it, and the first question, fifth, they requires it. The other just require to start your writing job. It does not require much of a thinking. Any question, you see the question, you get it, that it is from analytic geometry, it is from static, it is from mechanics, it is from linear algebra, and that concept should come into your mind. That all the methods of that topic should come into your mind, and you can start the calculation. No thinking required, and there is no time for that. And again, I think 4 to 5 minutes you can spend on this question. We can discuss it later. I don't know how many times this kind of question was asked. Almost every time. So almost every time, Laplace, Green's theorem, Stokes theorem, and Gauss divergence theorem, and this question. In section B, these questions are attemptable, no problem at all. So what was the question? This is from the vector. Show that there is a vector is irrotational. When we have irrotational, one we have, got the term, this is irrotational if curl is 0, right? And the second is, chalo, no problem, let us focus on this question. A vector is given is irrotational. You have to prove that this is irrotational. If you do not know what is irrotational, then nothing. What is irrotational? Irrotational if curl of a vector is 0. What is curl of a vector? Determinant of I cap, j cap, k cap, del by del x, del by del y, del by del z, and this over here, 6xy plus z cube, and write it down. Calculate this determinant, this has to be 0. If the curl is 0, job is done, first part. And the second, this is the direct formula. Any vector which is irrotational can be written as the gradient of your scalar potential. This is the simple theorem. So if it is irrotational, that means definitely it can be written as del of phi. You have to find that phi. Okay, you can just apply. The formula was itself given. A vector is equal to del phi. Apply the formula and find the value of phi. Catenary. This question was from catenary. Catenary principle. Curve is called catenary curve, right? Sag is there. Tension in the strings, tightly stretched. Horizontal tension, vertical tension. So this question basically requires all the theory part of your catenary section. Okay, catenary principle is required to solve this question. Okay, span was given. No, span you have to prove. Span of the cable you have to prove. Okay, sag is in the middle of the tightly stretched position. So catenary comes into the picture. After that, again, see, I told you method is specified. So that means you cannot leave any method. So like these questions are solvable by this method I find easy, so we will do that. No. once they have given you a method, and if you know the other method, you are solving that by other method, the no marks will be avoided, that is for sure. Okay. So, you can't miss any method. This was method of variation of perimeter. Again very simple, one solution was given, Wronskian is required, formula is required, fill everything y1, y2 linearly independence, Wronskian, this and you will get the answer. Okay. Easy. For the differential equation, okay, see Green's theorem, Stokes theorems, Gauss divergence theorems. In the second section, ये तो free के number है. These three theorems are just giving you marks as it is, and one is the Laplace. So Green's theorem, what is Green's theorem? And the region is also given. See how easy the region is. X is equal to 0, that means y axis. Y is equal to 0, that means x axis, and x plus y is equal to 1, x plus y is equal to 1. So A, B, C is the region. You define the direction also. Usually we define the direction also. So I have given the counterclockwise direction. Usually we do that. After that you have to verify the Green's theorem. Okay. So if you want to verify the Green's theorem, remember what is Green's theorem? Green's theorem is the relation between your single integration and the double integration. Basically it's all. Also it is not use the Green's theorem. I have seen students done that mistake. Oh, Green's theorem, we know Green's theorem, so apply the Green's theorem, tell the answer. They are not asking the answer. You have to solve the single curve integration, the line integral also, and the surface integral also separately, because the question is verify. So it's not like this seems easy, so you can solve it by the surface integral. No, you have to do both of the parts. So what is the theorem says? It is m dx plus n dy. Left hand side is already given in the question. So m you know, n also you know, right? And it is del n by del y. No, it was with respect to x, right? So n dx minus m dy and dx dy. This is your statement of Green's theorem. You have to solve left hand side, you have to solve your right hand side, and done, right? So a basic application. And also the region also was not difficult. See, it was very easy to draw these lines, x is equal to 0, y is equal to 0, and x plus y is equal to 1. In Stokes theorem, in Gauss theorem, they can make the question difficult if surface they are taking, for example, ellipsoid. For example, some curve you cannot draw in 3D. Right, because if we talk to the if we go to the Stokes and the Gauss divergence over there, but you see how easy this question was, because again we are in a plane. So in a plane I think you can make the diagram. So Green's theorem, Stokes theorems, every time. Stokes theorem. What is Stokes theorem? This is the relation between the, again a single integration, line integral, and the double integral, where curl comes into the picture. So this is basically f dot dr is equal to curl of f dot n cap ds. Now students, they struggle a lot for this n cap. Now the whole theory of this theorems is difficult because you cannot find your n cap, right? But see the question. What is your surface? A plane. I have done in the class even the question of ellipsoid. This was just a simple plane. N vector, not n cap. N vector is gradient of your surface. This is your surface. What is your surface over here? It's a plane. Substitute the value. You will get your n vector. N cap is just the n vector divided by n vector magnitude, you get your n vector, okay? And f vector you already have, you know how to find the curl. Over here also verify, it is not like only answer is required, you have to verify, so you have to solve this also, right. So again simple question for 20 marks. Now if you are making a wise choice in attempting the questions, because you have to do 5 questions at least, right, not at least 5 questions, attempting one from each section. So first question from first section is mandatory, you don't have any choice. First question of second section is mandatory, you don't have any choice. Now you have the choice for the rest of the 3, right. So if again you are struggling in mechanics, statics, analytic geometry, these kind of things, then you can go to these problems. In the second section, at least you can attempt the question of Laplace, Green, Stock and Gauss divergence. These are attemptable. And then again linear algebra portion you can attempt. In this section, B section also we had this subspace where we found that basis and dimension. So again make a wise choice of that, but again don't leave the topic, don't leave any topic, that I always say. Chalo. Laplace, you have to apply the Laplace both sides. There is a long list of Laplace formula. So basically with the differentiation formulas, integration formulas, trigonometric formulas, you must have the notes of the Laplace formulas and inverse Laplace formula also. Inverse Laplace, and make these small note like pages, staple them separately, like separate for differential, separate for integration, trigono, Laplace and inverse Laplace. Okay, and what is the key rule? What is the key of memorizing everything, and you don't have to forget also, because you know in total there are so many formulas. What was the keys? I told you, key is get up in the morning, just read it. Don't waste your time to sit and just you are sitting and then you are just memorizing the formulas again and again, repeating. That will not help you. A really basic concept, remember in schools, have you ever you have taken that time to memorize the prayer? No. Every day you recite the same thing. This is how it works. So every day, the first job after you wake up, read the formulas. Read the formulas, and if you get time, just before sleep, in the night also you can do that practice. Otherwise in the morning it is enough, right? And you recite the same thing again and again and again, and these formulas, they will not stop. Every topic will fill up something again, and you'll some extra booklets will be there full of formulas. Just recite them, just recite. Just say sin squared theta plus cos squared theta is equal to 1, sin 2 theta is equal to 2 cos theta, sin theta, cos 2 theta is equal to 2 cos squared theta minus 1. Just recite them, don't even make the repetition, right? This is the key step to you to learn all the formulas, and if possible just paste them on your door or on your wall somewhere, okay, where you can just aate jate you can just see it, right? Chalo. So again, in the starting also I have told you, Laplace, you just apply Laplace both side. The HT is required, so we need that formula where first principle, second principle, and then again by applying the inverse Laplace both sides, you can get the answer. Mechanics. Cylinder of the cross section is balanced on the another cross section, the contact of the curved surface being rough and the common tangent line. Okay, just a second. B and rho are the curvature of the two cylinders, this and the H with the highest of the center of gravity of the upper above the point of the contact, show that the upper it is equilibrium, stable and unstable equilibrium. This is the topic of equilibrium, right? We have the whole lecture on that is equilibrium. Okay, again because the question is proof something, so we need to have some work needs to be done over here as well. Differential equation, general and the singular solution and the geometric difference we have done so many times in the class. Okay. Variable coefficients are there, you need to change it to the constant variables and then you have to solve it. This is just this can be done by the substitution, by the right substitution. You have to just substitute 3x plus 2 dy by dx is equal to d by dx into some different operator, and this is the Euler's method. Direct question from Euler's method. Again we are in equilibrium, two questions were from equilibrium mechanics, and then this is the last question. This is the last question. Last question is 3 theorems always, Green, Stokes, Gauss divergence. Now if I know, and again see, we have done the Gauss divergence theorem on the ellipsoid, that is not even possible to draw over here. Z is equal to 0, Z is equal to 1, x square plus y square is equal to 4. This is a cylinder, the equation of the cylinder. How? X square is plus y square is equal to 4. In 2D it is a circle, in 3D it will be x, y, z. XY plane, on the XY plane this is a circle, so like that, circle on the XY plane. But I don't know if this condition is not required, is not given, then I don't know about the Z. So that means that is the cylinder of infinite length in that case, right? But I have the value of Z is equal to 0 and Z is equal to 1. So Z is equal to 0 means the XY plane, and Z is equal to means over here. So this is basically a cylinder like this. Okay. So this is Z equals to 0, this is Z equals to 1, this is x square plus y square equals to 4. Same question we have done, exactly same. I think F may be different, I don't remember about the F, because as soon as I have made this diagram, same question. Remember we have divided this question into the 3 parts. This is the surface S1, surface S2, and this is the surface S3, because for all of them you will get different n cap. For the S1 the n cap is this is positive direction of the z axis, k cap, n cap is actually k cap. For S3 it is downward, it is perpendicular, it is in the negative z axis, in the direction of the negative z axis. So over here n cap is minus k cap, but in the circle, over the surface of the sphere, you can't have a, everywhere you can't have a strict perpendicular. At every point it will be changing, at every point it will be changing. So over there n cap, n vector is given by that formula that I have done in the curl, that means Stokes theorem. In the Stokes theorem also I have written that. So same kind of calculation over here as well. So this question was lengthy but not difficult. Lengthy but not difficult. Again apply the Gauss divergence theorem. What is Gauss divergence? Gauss divergence is actually the conversion of the, from the double integration to the triple integration. So very important. This was it for the paper 1, right? So my basic observation says that calculus portion they can ask in the 23 exam, mechanics portion they can ask a little less in the 23, but it doesn't mean that you will have to take mechanics for granted in your preparation. Okay, you have to put all the efforts over there. Please go through these questions. They are not difficult questions, and the questions that were difficult, you have to analyze that in your exam so that your time is not wasted. Okay, it's very important to understand. Other than that, I'll come up with the second paper, paper 2 analysis, tomorrow at the same time. So I think this is it. If you have any doubt, you can ask me. Thank you so much for this session. Thank you so much.